Hello everyone. In this video we're going to be solving a radical equation. We have the square root of x over y plus the square root of y over x, and that sum is equal to 2 times the square root of xy. Okay, this is an equation, but there are two variables. What are we solving for, right? That's the million-dollar question. There's only two options. You can either solve for x or solve for y, and there's not going to be a huge difference because of symmetry. So we're going to go ahead and solve for y, okay? Now, how do you solve a radical equation? There's a couple ways to approach it. So let's go ahead and talk about some alternatives before we actually get to the whole thing. Now, since we have radicals on both sides, you can actually go ahead and just square both sides. If we had radicals on one side only and had some other terms, we would probably separate the radicals. That's one way to do it. Or another way to do it would be still square both sides, right? And every method is different and it usually depends on the problem. But let's go ahead and do this. Square both sides and see what happens, right? Great. So when we square both sides, we're going to get something like this. And let's call this the first method, okay? Because I'll be presenting more than one. So when you square the first term, the square root of x over y, you're going to end up with x over y, all right? When you square the second term, you're going to get y over x, great, plus the 2ab. Remember the formula for a plus b quantity squared. If you forgot, it's a squared plus b squared plus 2ab. Normally, in most algebra textbooks, they're going to give it to you a little different, like they're going to put the 2ab in the middle. But I like to keep these two together because it looks better that way. Okay, we don't need the reason, do we? So, and then the last term in this case is going to be 2ab, which is 2 times the square root of x over y times the square root of y over x. What about the right-hand side? We have a product, so it's going to be 2 squared, which is 4, times the square root of xy squared, which is just xy. Nice. What are we going to do with this, right? So, here's what we're going to do. First of all, we have two radicals. So we can go ahead and actually multiply these under the same radical like this. Square root of x over y multiplied by y over x. But wait a minute, isn't that equal to 1? Absolutely. That's why these two are reciprocals and they just totally cancel out. So that leaves us with x over y plus y over x plus 2 equals 4xy. At this point, it may not be clear how we're going to solve for y, right? But notice that we can make a common denominator, can't we? You can do this in different ways again. Let's subtract 2 from both sides first. That's probably going to be easier, so we don't have to deal with an extra denominator. Now make a common denominator. X squared plus y squared divided by xy is equal to 4xy minus 2. Great. Now, what are we going to do next? Well, we kind of need to cross multiply, right? And that gives us x squared plus y squared equals, if you multiply xy by itself, you're going to get x squared y squared minus 2xy. Great. Now, this would almost look like a nice quadratic equation, wouldn't it? If we didn't have some additional terms. So let's go ahead and do this. Maybe put everything on the same side, but which side are we going to pick? That's a good question, right? Depending on how you want to do it. But since we're trying to solve for y, it would make sense, and take a look at this. We have y squared, we have y squared, and we have y. So we can easily write this as a quadratic in y. Similarly, as an x, right? So let's go ahead and do this then. Subtract this and that. 4x squared y squared minus y squared minus 2xy minus x squared is equal to 0. First goal is to turn this into a quadratic equation, but we have one more step. These two have y squared in them, so we can factor out the y squared. In other words, the quadratic is going to be in y, remember? And the coefficient of y squared is going to be 4x squared minus 1. Does that make sense? And then minus 2x, and that's going to be the coefficient of y with the minus sign, minus x squared equals 0. What about x squared? That's going to be our constant term. Because this is a quadratic in y, anything in terms of x will be considered a constant. Just like derivatives or calculus, right? All right, now, what do? Since you have a quadratic equation, it's not easily factorable as far as I know. I mean, we could try 2x plus 1, 2x minus 1 from difference of two squares, and we could try different things with this, and it's probably going to work, but I'd rather use the quadratic formula. It's a lot easier. But again, you can try factoring this. I think it's factorable, okay? I have a feeling that it's factorable. So if you use the quadratic formula, y equals negative b, which is 2x, plus minus the square root of b squared, which is 4x squared, minus 4ac, 4 times a times c. And c is negative x squared, which is our constant term, so that's going to turn it into a plus sign. And we're going to subtract or add, divided by 2a, which is 8x squared minus 2. Beautiful, right? Let's go ahead and see if we can simplify this in any way. Now, inside the radical, let's go ahead and simplify this first. What is that equal to? Is that going to turn into something meaningful or not? Let's find out. So we have 4x squared. If you distribute 4x squared over it, it's going to be 16x to the 4th power. In other words, we're squaring this term. And then minus 4x squared. 4x squared cancels out. Beautiful. This is actually our delta, by the way. Because remember, in the quadratic formula, we have negative b plus minus the square root of delta over 2a. That's how you find the values, right? Exactly. That's the quadratic formula. Easier to memorize this form, right? Now, what are we going to do? We're going to replace the whole determinant with square root of this, which is going to be 4x squared, 2x plus minus 4x squared divided by 8x squared minus 2. Of course, this can be simplified a little bit. We can and split it up as well, but let's go ahead and divide everything by 2 first. X plus minus 2x squared divided by 8x squared minus 2. And then from here, you can actually write this in a more standard form, like maybe go with the minus sign first, like this, divided by 8x squared minus 2. And the other y value is going to be positive 2x squared plus x divided by 8x squared minus 2. Now, is there a way we can find this by factoring? Probably, because if you look at the roots, they're kind of good, right? I mean, they look cool, don't they? So you can call this y1 and y2 if you want, but it's the same idea. These are going to be the solutions. And remember, our goal was to solve for y. So let's go ahead and take a look at the second method real quick. I just want to show you a slightly different alternative. No big deal, but it's just another way to approach this problem, okay? So here's how it goes. First, we separate the radicals and then make a common denominator. So in this case, we're not squaring. Oh, by the way, one thing to check, because we squared both sides, we did not necessarily plug these in. Are both solutions going to work? I didn't check. Can you please do that for me, because I'm lazy? Okay, I'm going to leave it as an exercise for you, so don't hate me for that. We separated the radicals, and now we're going to make a common denominator, multiply these and multiply those. You're going to get x plus y here, and in the denominator, you're going to get square root of xy. Now, this actually gives you something different. Now, you're going to see what I'm talking about. When you cross multiply, you're going to get x plus y is equal to 2xy. And since we're trying to solve for y, wouldn't it make sense if we subtracted y from both sides and kind of put it on the left? And since we're trying to solve for y, factor the y out. 2x minus 1 equals x. And finally, y can be written as x divided by 2x minus 1. Wait a minute. Why were we not able to do the same thing here, right? Isn't that a good question? Well, here's the thing. You can do that, but you just had to do a little bit more work here. Let me show you real quick. If you factor out a negative x here, you're going to get 2x minus 1. And if you factor out a 2 here, you're going to get 4x squared minus 1. And then from difference of two squares, this is actually factorable. But does that give you the same thing? I don't think so. Why did we get different solutions? I probably made a mistake somewhere, but that's for you to find out. But anyway, second method is shorter. It only gave us one solution. So does that mean those solutions are not valid? Anyways, this brings us to the end of this video. Thanks for watching. I hope you enjoyed it. Please let me know. Don't forget to comment, like, and subscribe. I'll see you next time with another video. Until then, be safe, take care, and bye-bye.